Let's solve a couple of problems based on geometric progression. I'll begin with our first problem. So we need to obtain the geometric progression whenever the fourth term is 27 and the seventh term is given by 729. So let's begin. First, we'll have to specify the first term as well as the common difference. So let the first term be. We're going to represent it by the letter A in lowercase, and the common ratio is also going to be represented in lowercase r. Now it's given here that the fourth term is equals to 27. We know that the nth term of a geometric progression is given by the first term multiplied to the common ratio, and the common ratio is raised to the power of n minus 1. So for finding out the fourth term, we have a times r raised to the power of 4 minus 1, that's equals to 27. We have ar cubed equals to 27. We can label this as equation number 1. Also, we are given that the seventh term is 729. So that means we have a times r raised to the power of 7 minus 1. So that's 729, and this is going to give us a times r raised to the power of 6, which is equals to 729. We're going to label this as equation number 2. We will divide equation number 2 with equation number 1. And this is going to give us a r raised to the power of 6 divided by a r cubed equals to 729 divided by 27. So here a and a gets cancelled. R raised to the power of 6 divided by r cubed, that's simply r raised to the power of 6 minus 3. And 729 divided by 27, this has a value of 27. This means that our value, r cubed, is equals to 27, and 27 is simply 3 cubed. So we can say that r is equals to positive 3 if we take the positive cube rule. So our common ratio is r. Now we can obtain the value of a either by equation 1 or equation 2. So 1 will be much simpler. So let's use equation 1. We have a times r cubed. So r cubed is 27 equals to 27. So that means the first term has a value of 1. Now our task is to obtain the geometric progression. So the geometric progression will be defined by the first term. The second term will be the first term multiplied to the common ratio. So we have ar. Then to find out the third term, we have the second term, which is ar, and multiplying it to the common ratio r gives us ar squared. This is going to be the geometric progression. So here we have obtained that the value is 1. So 1 multiplied to 3, so we'll get us the second term. Then 3 multiplied to 3 is the third term. 9 times 3 will be 27. So this is the fourth term. Hence 1, 3, 9 and 27, these are the numbers that are in geometric progression. Let's move on to the next problem. So here also we need to obtain the geometric progression. It's given that the fifth term is 48 and the seventh term is 8 times the fourth term. So let's begin. So as usual, we will specify our first term as well as the common ratio. So I'll specify the first term by the letter a in lowercase and the common ratio as r in lowercase as well. So here it's given that the fifth term that has a value of 48. So fifth term means ar raised to the power of 4, that's equals to 48. So this is equation number 1. Then we have the seventh term that's equals to 8 times the fourth term. The seventh term means ar raised to the power of 6 equals to 8 times the a4, which is the fourth term, will be ar cubed. So here a and a gets cancelled. So we have r raised to the power of 6 equals to 8r cubed. Dividing both sides by r cubed, we have r cubed equals to 8, or r value is equals to 2. So we have obtained a common ratio as well. We will substitute this value back in equation number 1 to obtain the value of our first term a. So here we have a times 2 raised to the power of 4 equals to 48. This is going to give us 16 equals to 48, and we know the 16 times 3 is 48. So that means 48 divided by 16 is going to give us a value 3. So we have obtained our first term as well as the common ratio. So our required geometric progression, so that will be equals to, the first term is given by 3. The second term will be first term times the common ratio. So 3 times 2 is 6. Then we'll take the second term and multiply it to the common ratio 2. So this is going to be 12, which will be the third term. Then the fourth term will be 12 times 2, which is 24. So this is going to be our required geometric progression. Let's move on to the third problem. So here in problem number 3, we need to show that q squared equals to the product of p and s whenever p, q, and s is given by the 5th, 8th, and the 11th term respectively. So let's begin. So as usual, we will specify our first term as well as the common ratio. The first term will be a and the common ratio will be r. Now let's give now we can find out the fifth term. The fifth term is p. So our fifth term is ar raised to the power of 4. So this is equals to p. Let it be equation number 1. Then we have the 8th term, which is q. So 8th term is ar raised to the power of 7. That's equals to q. And then we have the 11th term, which has a value of s. So that means ar raised to the power of 10 equals to s. This is equation number 2 and this is equation number 3. Now what we'll do, we'll take the product of 1 and 3. So taking the product of 1 and 3, so this is going to give us ar raised to the power of 4 multiplied to ar raised to the power of 10. So this is equals to product p times s. So a times a will be a squared. R times 4 plus 10 will be 14. This is equals to ps. Now a squared r raised to the power of 14 can be also raised as ar raised to the power of 7 whole raised to the power of 2. That's equals to ps. And what is ar raised to the power of 7? That's simply q. This means we can replace the value of ar raised to the power of 7 with q. So we get q squared equals to p times s. And hence we have successfully showed that q squared equals to ps. Let's move on to the fourth problem. Problem number 4. We need to obtain the sixth term of a geometric progression. Here the second term is given. It has a value of 8 and the third term is square of the, not the fifth term, there is a typo here. This is the first term. So it's the third term is the square of the first term. So let's begin. Now our first term, let's denote it by a or simply a1. It means the same thing. Then we have the common ratio denoted by r. Now it's given that the sixth, we have to find out the sixth term. The second term of the geometric progression has a value of 8. So we have a times r. This is equals to 8. And let this be equation number 1. Also it's given here that the third term equals square of the first term. So that means a3 equals a squared, ra3. So that will be ar squared equals to a squared, or r squared will be equals to a. Now what we can do, let this be equation number 2. We'll substitute the value of a with r squared in equation number 1. So equation number 1 gives us a, which will be r squared multiplied to r equals to 8. So r cube will be equals to 8 and this gives r value equals to 2. So we've obtained the common ratio. Now we can use this to obtain the value of our first term a. So a will be equals to r squared, which is 2 squared. This is going to give us a value 4. So we've obtained the common ratio as well as the first term. So therefore the sixth term a6 will be ar raised to the power of 5, which will be equals to the first time 4 times 2 raised to the power of 5. So we have the 128. So this is going to be the value of the sixth term. Let's move on to the fifth problem. So we need to obtain the seventh term of a geometric progression when the first term is given by -3 and the fourth term is square of the second term. So let's begin. So here we are already provided with the value of a first term. So our first term, if we represent it by the letter a, so this is going to be equals to -3. Then we don't have the common ratio defined. So let's say the common ratio is denoted by the letter r in lowercase. Given that the first term is already given, the fourth term equals square of the second term. So fourth term means we have ar cubed. So this is equals to square of the second term. So that means ar raised to the power of 2. So ar cubed will be equals to a squared r squared. So we can divide both sides with a squared r squared. So we have ar cubed divided by a squared r squared equals to 1. Or simply r divided by a equals to 1, which gives us r equals to a. Now a value that equals to -3. So that means our common ratio is also -3. So we have obtained the value of a common ratio as well as the first term. Now we can obtain the seventh term. The seventh term is given by ar raised to the power of 7 minus 1. That means a times r raised to the power of 6. substituting the value. So we have negative 3 multiplied to negative 3 raised to the power of 6, or simply negative 3 raised to the power of 7, which is going to give us a value negative 2187. So let's move on to the final problem. We need to show that the four numbers a, b, c and d are in geometric progression if we have this particular relation. So let's begin. So first we will consider a plus bx divided by a minus bx equals to b plus cx divided by b minus cx. So we will simplify this particular equation by using the method of component and dividendo, which means that, let's say, if we have the ratio a over b equals to the ratio c over d, then the component and dividendo says that if we can rewrite this expression as a plus b divided by a minus b equals to c plus d divided by c minus d without affecting the ratio or the equation. So that means in our case we have a plus bx added to the denominator, which is a minus bx, divided by a plus bx minus a minus bx, which will be equals to b plus cx added to b minus cx divided by b plus cx minus b minus cx. And now we're simplifying. The numerator bx will get cancelled, so we have 2 times a divided by 2 times bx, which will be equals to 2 times b divided by 2 times cx. Further simplification gives us the value a over b equals to b over c, or simply put, we can have b over a is equals to c over b. Let's label this as equation number 1 for the time being. Then we will use the second part. We will consider the second ratio and the third ratio, b plus cx divided by b minus cx. This is equals to c plus dx divided by c minus dx. Now again applying the common method of component and dividendo, so where b plus cx plus b minus cx, the denominator, we're adding to the numerator, and we have b plus cx minus b plus cx equals to c plus dx plus c minus dx divided by c plus dx minus c plus dx. So here positive cx, negative cx cancels out, then positive b, negative b, and on the left or right hand side we have positive dx, negative dx, and positive c, negative c cancelling out. So this gives us 2b over 2cx equals to 2c over 2dx. Now further simplification gives us b over c equals to c over d, or simply c over b equals to d over c. That this be equation number 2. So we can compare equation number 1 and equation number 2. We can combine them to get the final value. b over a equals to c over b equals to d over c. So this is what we are getting by equating 1 and 2. This simply implies that the four numbers a, b, c and d are in GP. All we have done is dividing the second term by the first term, which gives us a common ratio r, and this common ratio is going to be exactly equals to taking the ratio of the third term to the second term, or the fourth term to the third term.